Hey Algebra 2, here we are with our 1-3 function review. And this first page is more just putting everything together. So when we talk about what are we looking at here, our review is going to help us talk about things. And this is what I want you to really think about. When you meet a new friend, what type of questions might you ask them when you're getting to know them? Pause the video and add some questions that you would ask a new friend. So these are some of the questions I came up with. Maybe what kind of music somebody likes, maybe where do they live, whether they have brothers and sisters, what kind of food they like to eat, any movies or TV shows that they're binge watching or streaming, what books they like, or maybe if they like sports. So here's the deal. When we're talking about functions, we need to get to know our functions in the same respect. When we ask, is it a function, what this means is that it passes that vertical line test. And every input has a unique and predictable output. When we ask about those input and output values, that means we're talking about our domain and range. Our domain is going to be our x values, and we're talking about on the coordinate plane, what left-right boundaries. If I talk about my domain, I'm asking you, where does my graph exist on a left-right scale? When I'm talking about my range is, if I consider this same graph that I just kind of sketched here, my range is going to be looking at, hey, what are my up-down boundaries? How high or how low? Whenever we talk about domain and range, we're going to make sure that we use interval notation. So if I have x1 and x2 here, I can say from x1 to x2 is my domain. If I have my range, and I have y1 and I have y2, maybe what I could say is my range values are from y1 all the way up to y2. Our intercepts are where we're looking at where our graph crosses the x and y axis. So our x-intercept is this x value that gives me an output of 0. We care a lot about these. We call these the zeros and the solutions. So our x-intercept is always going to be where it crosses our x-axis. Our y-intercept is going to be where the graph crosses our y-axis. Here it is. And this you remember from the b in our slope-intercept form, y equals mx plus b. When we talk about whether or not a graph is increasing or decreasing or constant, this was our conversation about where our ant was traveling. And we want to make sure that we remember that this is an x value conversation. As the ant travels left to right across our graph, what x values is he increasing, what x values is he decreasing, and then where he goes. And we always talk about it in interval notation, and we're always going to use parentheses. If we're wondering if the graph is a one-to-one story, that means that there's no repeats in the range. So that is a horizontal line test. And if you want to think about why that's true, I want you to think about, let's go ahead and consider a quadratic equation. So if I had this quadratic equation that looked like this, notice it fails the one-to-one test because this output happens from two different inputs. So we want to make sure that if it's going to be one-to-one, it passes the vertical line test. If it's continuous, you can trace your entire graph using your pencil without picking it up. And the things that are going to make it not continuous is if I have a hole, if I have a jump, or an asymptote is going to be where my graph approaches but never quite reaches something. When we're talking about end behavior, we're looking at where is this graph going? and we're looking at the output, and we're like crossing a street, you're looking both ways. As x approaches negative infinity, where's the output going? As x approaches positive infinity, where's the output going? So that's a good question to keep in mind. Are there minimums and maximums, and what kind are they? So an absolute minimum or maximum is going to be, for example, where the graph stops and starts. A local or relative maximum or minimum is if maybe you have a graph with lots of hills and valleys. So if I have a graph that looks like this, these two are going to be relative maximums, and these 2 points here are going to be relative minimums because this graph continues on in both directions forever. Keep these questions in mind when we talk about and go through the next couple graphs and questions.